Yep.
Yes.
Thank you, Gaston, and thank you everyone for joining today. Good morning, afternoon, evening, where you're based in the world. Um, my name is Fernando Honig. I'm the CEO and founder of Staxon, and as Gaston said, it's a pleasure to be here today, talking a little bit about security on particularities here. So if you have any question, please feel free to write them on the chat, and we'll be more than happy to answer it. If you by the end of the presentation want to unmute yourself and ask questions, happy to reply if I know the answer. If not, I'll be more than happy to guide you through a potential documentation. Okay. So without further ado, let's get into this. So the question is here, how many of you know about this? So in 2022, 18.9% of cloud native threats were directed to AWS. So AWS by far is the main target for threats. But for me, the thing that really caught my eye in these statistics is how many businesses were hit by ransomware in 2021. We don't have the number for 2022 yet, but it's 37%. 57% only recovery functions given to it. And the amount of money that cost on average to businesses to recover from an attack in 2021, 1.85 million on average. So with all this information, it's very important to keep security as job number one. Everything starts with security. When we talk about the three main principles, we know here protect, monitor, and remediate. So the first thing here is essentially making sure that we are protected. But because we don't know where these threats could come from, is that we need to monitor. We need to be sure that every single resource that we deploy is essentially monitored. And if by any chance something happens, we don't want to be awake 2 a.m. in the morning on a Sunday. What we want is to essentially being able to remediate itself, fix that little hole in our firewall or in our environment, right? So let me introduce a few services that we have available on AWS. For protection, today we're going to be talking on a solution that involves Amazon Guard Duty, AWS Lambda, Amazon Event Bridge, Amazon CloudWatch, and Amazon SNS. For the ones that are not familiar with these services, I'll try to be quite brief on what each of these services do. Amazon Guard Duty essentially is a threat evaluation service. What we do with Guard Duty is analyze different services or resources that we have on the AWS cloud and provides a simple mechanism to give us this sort of a idea of what's going on with our services. So it reports back to us, and we can put these alerts into CloudWatch. So, and CloudWatch also can send these to Amazon S3. AWS Lambda is the serverless compute service launched in 2015. Maybe most of you are familiar with it. With Lambda, we can execute code in milliseconds. It starts the execution, runs something, and then eventually dies. So this is essentially the main concept of the serverless architecture. Event Bridge initially started as part of CloudWatch, and then it evolved into its own product. And an Event Bridge, what allowed us is to treat these notifications as events. So when something happens with Event Bridge, we can essentially filter those events and use as a trigger to execute something else. CloudWatch is one of the first or the main services on AWS. So everything gets monitored and metrics are generated on CloudWatch for different resources that we create in our AWS accounts. And SNS is the notification service. It's essentially a way to receive notifications either via email, SMS, HTTP, or eventually we trigger again a Lambda function through SNS. Again, if you have any question at this point, please feel free to reach out on the chat, and we'll be more than happy to answer it in a moment. So these are the 5 services that we're going to be using in this particular example that I'm going to be giving to you. So in this case, what we are going to do is we are going to protect our network by using these 5 services. So imagine that you have an environment, and within this environment, in an AWS account in a particular region, a VPC, And in this VPC, obviously, you have a subnet and you have some EC2 instances as part of an environment. So 2 a.m. morning, you just start receiving root force. But you in the you force. See? So events, and we grab this event with event bridge. So we have a rule in event bridge, and this event rule, an event that it will trigger Lambda. So what this Lambda is going to do, first of all, is going to write the execution of this piece of code into CloudWatch. It will create a log in CloudWatch log groups, and it will do 3 things at the same time. One, it will create a network ACL entry in our VPC, in our subnet. It will create a record in DynamoDB, indicating that this particular IP that is kind of offending us started offending us on the next particular day. And then it will also notify us via SNS. At this point, we are protected. So we just stop this offending IP. We also have a time limit, because IPs are dynamic, so we cannot start blocking everyone, and eventually we need to remove this entry from DynamoDB. So essentially what we have in DynamoDB is the record that has the date, that has the IP, and has when this needs to be removed. So then we have a Lambda that is going to be triggered by a time-based event. So this delete NACL event that we have on the right, so here, essentially is going to be triggered every hour, and it's going to start checking which are the entries that we need to delete. When that is checked from the DynamoDB table, then we're going to, this delete Lambda NACL deleter function is going to delete the entry from the subnet network ACL. Because we can have this solution in multiple accounts and multiple regions that you potentially have in your AWS organization or AWS environment, we need to somehow have a central place that it will send all emails to the, let's say, security team or to the on-call team, okay? So that's why we have a local SNS topic that is sending this event or this message to a central SNS topic, and then we can have different emails here. This solution is not only for SSH brute force, it's also for RDP, port probe, unprotected port, black hole traffic, XHOL DDoS, or Tor IP caller drop point. So what we are doing here is we are enabling guard duty to monitor network events. We create an ACL rule and introduce the offending IP to block it during a certain amount of time, and we notify it to a distribution email list when an action is taken. In this case, when we are adding this network ACL entry, and obviously when we are moving the entry, so we know exactly if it's a repeating event, then we can potentially manually block it for the amount of time that we need. Then we have the monitoring. Yeah. Yeah, so in that case, so you have basically different uh, options. So you could trigger the Lambda straight from SNS, so you just indicate which. So with SNS, you have different, let's say, destinations. So one of those destinations could be basically Lambda. So in this case, it doesn't matter because basically your ECS, it really depends if your Fargate is in a public in a public subnet, really, because as we saw here, let me go back on the here. So these should be a public subnet in order for the offending IP to reach this EC2 instance. So in this case, if you have an elastic load balancer and your Fargate cluster is in a private subnet, which is kind of a best practice, this should never happen to you. And if you have an ELB, then probably is another solution that you need, which is WAF or Shield, which are other two AWS services. So right. So please, guys, keep questions coming. No worries. Happy to answer if I know the answer. So for monitoring, we have 4 services. Kind of the same services that we spoke before, but used in a different manner. So in this case, we have AWS Lambda, we have Event Bridge, we have CloudWatch, and we have SNS. So in this case, the use case is how can we make sure that when our developers are uploading new Docker images to our ECR, then these images are scanned and we have a specific threshold to notify when vulnerabilities are found in these ECR images or in these Docker images. So in this case, what we have is we need to ensure that all our Docker images uploaded to ECR are scanned for vulnerabilities in each region and account, because essentially what we want here is making sure that every account is protected, every ECR repository is protected, and also to create alarms when this happens. Again, remember that we don't want to be, notified at 5 a.m. in the morning, 7 p.m., whatever the time is, that we're having vulnerability and someone is, brute forcing our application. So in this case, what we do is, whenever you upload a new Docker image, the specific repository in ECR needs to have scanned image enabled. When this image is scanned, that triggers an event, and that event is captured by Event Bridge. We have a scan event rule, which essentially triggers a Lambda, and this function does 2 things. One, it creates log group entries into CloudWatch log group by repository. And then it also creates an alarm when the threshold that we have surpass that the number of vulnerabilities. So then it triggers a message on the SNS topic that we have configured in this particular account and in this particular region. And again, what we do here is we push that notification into our security account, where we aggregate all the messages from all accounts and regions. So as you can see here, we can scan our ECR images by vulnerability. So we define what's going to be our threshold for high vulnerabilities, for medium, low, and information. And as you can see on the image down here, this particular repository gets a new log group, and then we have 4 log streams, one for each vulnerability. And here is where we can see how many vulnerabilities each image has at this point in time. And then we have this last piece, which is remediate. So we're introducing here more services. So in this case, we're going to be utilizing Systems Manager. And within Systems Manager, we will have automation and documents in order to trigger these self-healing / remediation actions. And in order to understand what's going on with our resources, we're going to use a service called AWS Config. So AWS Config, what it does, it monitors whenever you change a resource, whenever you create a resource, or every certain amount of time, the state of these resources. And the way that it does is by comparing what you have versus what is best practice. So in this case, what we want is to make sure that we remediate the state of a resource. So we will need to ensure that all of my S3 buckets are encrypted, are versioned, and public read-write protected. What it means is that we don't want anyone reading my S3 bucket objects or writing to my S3 objects. So for that, what we have is AWS config rules. So these rules, essentially what they do is they monitor 24/7, no matter if it is holidays, no matter if it is a non-working day, every time that your buckets are encrypted, versioned, and they have public read and public write prohibited. We want to ensure that all our SNS topics and new EBS volumes are encrypted with a particular key. So this is very important because, if someone gets access to, for example, I don't know, a snapshot that you have or whatever, they cannot access the data on it. We want to make sure that our DynamoDB tables have a point in time recovery, so we can go back to a specific time and with that we can roll back in case of a potential rollback situation. We want to enable that every VPC has VPC flow logs, which means that we will be in a position to understand the traffic that is happening in our VPCs, and we can read that in CloudWatch logs. We want to ensure that no elastic load balancers or RDS instances can be accidentally deleted, which means that if, for example, you create a database and then you just go to actions, delete, it will say, no, you cannot delete this RDS instance because it's deletion protected. So you need to do kind of think twice about deleting an RDS and making sure, do I need to really delete this database? Or even if you do it with an API call or a CLI command, right? So the idea here is that you have kind of an extra step to deleting an RDS instance, or in this case, also a load balancer. And also, we want to define and enforce a security password policy. So these are kind of the best practices from an IAM password policy point of view. So we want to make sure, for example, that my IAM users have, I don't know, 12 characters password, and they have a, I don't know, lowercase, uppercase, symbols, and for example, that the password needs to be rotated every, I don't know, let's say 60 days or 90 days. So how do I make sure that I can implement all of this that we just spoke about on the left with config rules and remediations that I have on the right? So I just put this number of rules. So this is all public. This is all available for you straight from the AWS console and an API and SDK. So these are the names of the rules, and these are the name of the remediations that you can execute as soon as one of your resources becomes non-compliant. Non-compliant means that, I don't know, your DynamoDB table does not have a point-in-time recovery enabled, or that your SNS is not encrypted, or that your S3 bucket is not version, So this is a very interesting way of making sure that your resources are following these best practices. And in case that you create a new bucket or a new RDS, and you forgot to make it versioned, or you forgot to enable VPC flow logs in your shiny new VPC, well, it will automatically do it for you. All right. And obviously you will receive, if you define a notification that will say, hey, this resource is non-compliant, we just executed this remediation, your resource is now compliant. So these are kind of the resources and services that you can use straight out of the box with AWS. We have a case study here. And bear with me with the complexity of this customer and basically what this customer achieved in such a short amount of time. So this is a customer called Green Empire. So Green Empire basically is an e-commerce platform that offers eco-friendly products. It has around 20 million daily operations. Their engineering team is about 40 people, different skill sets, but only 2 fully assigned to these DevOps/SRE responsibilities. They deploy the application in 4 environments, each of them in a dedicated AWS account, just for de-risking in case that a developer gets into production and copies the database, the production database, into QA just to make some changes. So the idea here is that we isolate environments and we build different access and authorization. Then we have what we call a landing zone. So a landing zone essentially is a number of accounts dedicated for a particular purpose. So in this case, we have the log archive account where we're going to collect all the logs from, for example, CloudTrail, and make sure that all your API activities are logged in a specific account that can be used for audit and potentially trailing. Then we have another account, which is the one that briefly commented before, which is the security account. So in the security account, what we can do is aggregate some specific config information. So in this case, let's say that you want to have a holistic view of your resources and the compliance state of your resources. So in this security account is where you can create a config recorder, and you can have an aggregate. So it aggregates data from all your accounts and regions. And also you have the shared services account where you can place uh, specific resources that are going to be shared among all your environments, and the networking account where you can potentially aggregate all your outgoing network. So if you want to install any IDS, IFS network device, you can put it there, and then you can send all your traffic to this particular account and kind of monitor what's going on. So this is what we call the landing zone. So in total, they have 10 AWS accounts. They have a pretty tight RTO, which is the time to recovery in case of a particular incident. So they cannot have more than 1 hour downtime. Otherwise, they can lose up to 800K an hour if that happens. And they can only operate and place customer data in European cloud regions. So for certain data restrictions, they cannot put things in other regions than the European one. So this is kind of a definition of our customer. So this is kind of the architecture they have. So they have Route 53, which is the DNS service. On AWS, they have ELBs as entry points. They have EC2 instances for the web services. And also they have Fargate. It's very interesting, the question about Fargate that was in the chat before. So they have ECS Fargate for the API REST services. They use RDS, so the Amazon RDS database service for customers and purchase orders. And also they use DynamoDB for cache and session handling. They use the Amazon Elasticsearch service for the search engine. They use CloudFront and S3 for the static web content. And for the Fargate, they use ECR to store all the Docker images that are using for that. So as you can see, the first kind of a 3 items that we spoke before, so making sure that their VPC is protected using Guard Duty, that their ECR Docker images are monitored by using this solution for trying to catch vulnerabilities, and making sure that the remediation happens in case that their packet is not encrypted, or their DynamoDB table is does not have point-in-time recovery, or their database is not protected against termination, accidental termination. Okay, so as you can see, the 3 main aspects that we spoke before can be applied mainly to any architecture and platform. So in this case, as I mentioned, they have 10 AWS accounts. They can only deploy in European regions, so they deploy in Frankfurt, London, and Ireland. And essentially, the need is to automate best practices, security compliance, ensure their RTO is lower than an hour, deploy alarms dynamically based on the resource types, constant monitoring of objects and anti-malware files, have some vulnerability scanning of container images, and ensure that the resources are deployed on enabled cloud regions. So the challenge here is only 2 guys. So only 2 people are part of this team. There are multiple environments, as I mentioned before. They have dev, QA, UAT, prod, etc. These environments are quite dynamic, because with Fargate, you just have an instance, or this cluster creates tasks, and basically these resources go up and down, and they want to they have some sort of industry security baseline requirements. So what was the solution? The solution was to deploy around 100 AWS config rules. Rules are deployed again in different accounts and regions. Almost 90 systems manager automation documents, which is the one that we briefly spoke before. Some AWS backup for with this multi-account, multi-region, right? So making sure that the AWS backup is backing up EC2 instances, RDS instances, S3 buckets, Elasticsearch clusters, etc. So that is the kind of the idea of enabling AWS backup and creating a vault in every account and region. Service control policies to restrict regions. So basically, we managed to deploy these service control policies and making sure that regions that are not the ones where the customer needs to deploy or is not allowed to deploy is never going to be enabled. So from a service control point of view, you can limit that, and no matter if you are root in a member account, you cannot deploy things in a region that is not enabled. Also, the important thing here is around a centralized Amazon Guard Duty and enabling anti-malware and DDoS auto-remediation, which is a solution that we spoke before, and making sure that their images are continually monitored and have some automated alarms. So as you can see, is a bunch of resources, a number of configurations that need to be done, and we managed to do it in 6 hours. So the question here is how? How can we do this in 6 hours or less? So essentially what we did here is we enabled Staxon for them. So Staxon is essentially an AWS cloud governance solution for multi-account environments, which is purely based on well-architected framework best practices. So the well-architected framework is what AWS suggests as the best practices for utilizing their cloud platform. It's kind of the starting point for new or existing workloads. In this case, it was an existing workload, so they had these accounts, and we basically built this landing zone for them. So it contains more than 200 config rules that you can pick and match depending on the resources that you have and your specific industry regulations. It also has these remediation rules that I mentioned before, but also it adds more in terms of aggregation. So as I mentioned before, Macy aggregation to making sure that whatever you put in your buckets does not contain sensitive information, for example, or personal identifiable information. We also have, as part of Staxon, an S3 antivirus, auto patch management, policy guardrails, and which basically allows you to, with some tags, enable automated triggers. From a cost control point of view, we have different saving plans, alarms. We have different AWS budgets that you can configure and alarms that you can configure for your budgets. And essentially, the main thing here is time-consuming operations can be solved with a single click. So the question is how? And let me share with you this very short video that will explain what and how can this be done with Staxon in a few clicks. So in our provisioning module, you have these AWS config rules regional, where we define these rules based on the different services. And once you enter into what we call the edit mode, you just modify this configuration and you say, okay, I want to enable this particular rule, or I want to disable this particular rule. Or in this case, we are enabling also remediations. So we want to make sure that all our S3 public all our S3 buckets are publicly denied. So once we essentially save this configuration, then you can go and move to a second rule. So in this case, we want to enable this rule, which checks that every EFS file system is enabled, is encrypted, sorry. Or for example, if we go to RDS, we want to make sure that our RDS is checked for encryption and public access. We don't want anyone to access our data. And also we want to make sure that deletion protection is enabled. And if an instance is not with instance deletion, we can have this remediation as well to modify instances and making sure that is basically with deletion protection. When you define everything, then what you do is you deploy that configuration, and this configuration is deployed to every single account, every single region that you have, making sure that you have kind of this control and governance in every single account that you have. Most importantly is that, let's say you tomorrow need to create a brand new account, you can have the exact same configuration in all your in this new account. So you don't have to kind of reconfigure or go to the account and enable or disable regions or enabling or deleting rules. So this is a simple way, and it can be done a brand new account in, I will say, in between 20 to 40 minutes, depending on the number of rules that you have and remediation that you have enabled. So let me go to the next one. So in this case, again, is how do you enable, for example, CloudWatch alarms, right? So typically it takes a lot of time to define an alarm, set up the alarm, create the alarm, put it in every account, and also in every region. So with Staxon, you just click with different toggles that we have, and you enable the different CloudWatch alarms. You just save settings, and when you do that, again, this is deployed on all your accounts, every single region that you have enabled. And let me go to the next one. And here we go. So some automation facts out of this, right? So with Staxon, we essentially go up to 87% of compliance after implementing it. So the 87% is around all the security best practices compliance. We are in a position to deploy more than 200 control points in every account and every enabled region that you define. And these can be deployed in 6 or less hours. So imagine deploying 140 CloudWatch alarms, 1,300 security controls, more than 23 service control policies, and 820 self-healing controls. I don't think any human can do that. And the most important thing as well is that these gives you an idea of what you actually have in your environments, which leads into how can I reduce the cost that this is causing me because I forget to I don't know, terminate instances or empty some S3 buckets, etc., etc. So by implementing these remediation and monitoring of these billing budgets, then you can essentially take control back of your cloud spend. I'll leave some time for questions now. Again, happy to answer any question. Happy to go back to any slide. But in case that you are looking to implement any of these that we talked today, please go ahead. You can go to staxon.com/demo, and we will be more than happy to book some time with you and start kind of diving into what the needs are in your particular environment, and how we can solve it with Staxon by enabling these three main principles, right? Protect, monitor, and remediate. Probably, if you're a bit shy, and you can just type it on the chat. Happy to reply.
I'm just curious, would you be sharing the presentation or this documentation that you've presented today? Thank you, by the way, for all this information.
Thanks, Ashish. Yes, yeah. So we'll be sharing the presentation. The video will be also available. It's on our social media. You will find it in our LinkedIn and also in our YouTube channel, where also you'll find more videos around how to enable different things using Staxon.
Great, thank you.
Hi, Aditya. Yes, so basically on our website, you will see a lot of our case studies, specific case studies on specific problems that our customers had in the past. So yeah, more than happy to share those case studies with you. Thank you, everyone. Thank you for your time. I know it could be very late in the evening for some of you. It could be very early for some of others. So appreciate your time, and thank you for listening.
Thanks so much, Fernando.
Thank you.
Okay.
Bye-bye.